what time am I available tomorrow to do this extra thing? Maybe, what time are you guys free? Let's say if I do 4 o'clock, is that okay for you guys? If I do 4 p.m., is that okay? 4 to 5 or 4 to 6, maybe. 4 o'clock for what? For for the extra time to cover the questions I didn't do or I cannot do. 3 is not okay for me. Wednesday, tomorrow, yeah. After 4 is okay, but 3 is not okay for me. So before 3 p.m., I'm not free. So maybe if not 4, what about 5? 5 p.m. Anyone not free at 5? Tomorrow. I'm not free today. Wednesday, 5 works too. Okay, so looks like nobody said 5 is not okay. Post the recording. I'm still thinking if I want to post the recordings. We should do a poll. I cannot start a poll anymore because the Zoom meeting has started. The Zoom poll is like you can only do it before the Zoom meeting. 9 p.m. flex. Only send it to people in the tutorial. Cool, that's fine with me. Okay, I'll send you the link if you are here. Because we're trying to encourage people, give you benefit if you are here. So I'll record it and I'll send you the link if you are here today. Okay, so we'll do 5. We'll do 5 p.m. tomorrow. So I'll write it down. 5 p.m. So whatever I do not finish today, we will finish them tomorrow. So 5 p.m. On Wednesday. Okay. Well, I'll finish whatever I have left. So it might not end at 6 p.m. Might be 7 p.m. I don't know. So we'll do 5 and onwards until I finish everything I want to cover. That's it. So 5 p.m. tomorrow on Wednesday. If you cannot make it, but you are here today, I will send you the recording. I'll send you a link of the recording. All right, that's it. So let's talk about today's material. People, tutorial 3. This part is what people find the hardest. I don't know. It's maybe because people do not understand the definition. I'm not sure. So we will start from the definition first. Sorry. So image. Let's read the definition together and I'll try to explain it as much as possible. I think it's because we've been taught functions very differently in high school. We have been taught everything very differently in high school. So high school math is fake math. Anyway, back to this. So what is image? You have a function that maps from A to B. So A is called the domain. What is domain? Domain is what your x can be. So your x are picking from the domain. So this is what your x value can be or what your input can be. B is called the codomain of the function. Okay, codomain. So in high school, you don't even have this. Okay, because they don't even give you domain. So you're only dealing with real numbers. You're not restrict your domain to anything else. Probably why people are not used to this. I do understand. This is codomain. This is what your y could be. Okay, what your y could be does not mean your y has to be one of them. It's not range, it's codomain. So it contains a range, but it's not range. So this is what your y could be. So for example, I'm gonna say, give you an example. Let's say f mapping from R to R, and I'm gonna say my f of x is x squared. Then in this case, you know that, well, this can never map to the negative numbers. However, my codomain is all the real numbers. So the image of this does not equal to this, but this is codomain because, well, your x come up to real numbers. Okay, so those are possible y value. Doesn't mean your y can actually be all of them. It's possible y value. So codomain is a possible output, but image, okay, image of f is the actual output. So what can your x actually map to? So in this case, your actual output or the image we denoted by f of domain. So this is image is gonna be from 0 to infinity. Okay, so this is what you can actually map to, but codomain is the possible outputs. Okay, so possibly you can map to them, but not probably not actually them. Does that make sense? Do you understand the difference between image and codomain now? So let's talk about the range. Range is mainly used in calculus courses. It's, if we talk about range of a function, it's actually equivalent to image of a function. So I'll probably write that as well. So range of a function is also image of a function. Okay, so if you're more familiar with the word range, you can use it, of course, why not? But you should be more familiar with the word image because it's more accurate. Can you repeat about codomain of an image? I will use a really bad example to explain the game, so just hold on to it. Remember this part, okay? So, and also image of a function is always, okay, image, where do you write it? Image of a function is always a subset of codomain. They might not be equal, but it has to be a subset. Yeah, exactly. Thank you. Okay, so that's how it works. Now, let me give you a really, really bad example, but I think it would make sense to you. Okay, I use this example every year. It's really bad. Dating show, yeah. This time I'm not gonna use dating. I'm gonna change my example slightly a little bit because I think it's more accurate to do it. So again, we'll still have a dating show. Okay, we'll still have a girl and boys dating show. And now, so this is my domain. And I'm gonna say this is my codomain. Okay, so this is my domain. And I'm gonna say this is my codomain. And again, I'm gonna say in my domain, I have a bunch of girls. So my domain has girls in there. And my codomain, we have boys in there. Okay, so we have some boys in there. Now, I'm gonna say, oh, in this dating show, we let them will spend one day with each other. So they're all together spending one day with each other. And at the end of the day, we're telling the girls, you can message one boy you like. Okay, you can send one message to someone you like, to a boy you like. Suppose there's no lesbian here, okay? Suppose we could have lesbian, we can have lesbian show where we have girls and girls, but anyway, suppose I don't want to do I don't want to do girls and girls, because why do those girls have to like girls on this side, right? They might like them, which is not possible here. So I'm not doing gay or lesbian, or we're doing only straight. Okay, for now only straight, so it's more accurate and makes sense to us. So let's say at the end of the day, each girl sends one message to a boy they like. So you might ask, oh, what if I like two different boys? You cannot do that. Okay, you cannot do that because you are only allowed to send one message. Also, you don't say you don't like anyone. You have to send one message. Okay, you have to send one message. So now my girls on this side. Okay, I have too many girls, so let's remove some. Sorry. I didn't kill them, they just left the show, okay? So now, now they're gonna send a message. So this girl's like, oh, I like this guy, right? And this girl's like, oh, I like this guy. And this girl sent a message to this guy. And this girl's like, oh, I also like the first guy. So they send a message to the first guy. And this girl's like, oh, I like you. And this girl sent a message to this guy, okay? So suppose that's what they did. Now, okay, now let's look at the boys. We will have those boys, okay, those 5 boys, they got a message or 2, but they got a message, so someone likes them. So the boys who like, someone liked them those are my image. So those are my image. Okay, however, we have boys here. Okay, nobody likes them. So the boys nobody likes, they are in my domain. No, sorry, in my codomain, but not in my image. So it's like if someone likes you, you're one image, or you're in the image of the function. If nobody likes you, then you're not in the image, but you're still in the codomain. Does this make sense to you? It's a bad example, but this gives you, an intuition of how it works. Make sense? Okay, so how do we prove the image of a function equals to something? Look at this, okay? Guys, look at this carefully. I'm going really slow because I want to make sure you understand what we're doing here. So if the image is not given to you, then you need to find it using whatever way you want, okay? We do not care how you find your image. We only care about the proof. So remember, in 102, we only care about the proof. However you found your image doesn't really matter. So if you want to use calculus, you use calculus. If you want to draw the graph out, you can draw the graph out. So decimal is okay. I'm not gonna say that because I don't know if you are allowed to use decimals during the quiz. But use whatever way you want, and do not commit academic offense to find your image. If all the image satisfy all the codomain is zero term that, so you're saying we have happy boys here, nobody's lonely, and everyone got a message from girls. They're saying my image equals to codomain. Yes, the word is called surjective. If image equals to domain, then if image equals to codomain, then the function is a surjective function. Okay, which you'll learn very soon. So you'll learn injective, surjective functions, and this example will come back to you later in the course. But anyway, so find your image in whatever way you want, and what you write, surjective. Okay, right here. So let's say if no sad boys, everyone's happy, then they got a message, then the function is called a surjective function. Or an onto function. Anyway, come back to this. So what you should write on your quiz or on your assignment is you should claim the image you found is indeed the image. Okay, you should make a claim. You say, claim that the image of this function is 0 to 2, something like that. Okay, so here, claim f of domain equals to a to b. So I'm gonna use this as my example to explain the rest. Okay, now listen carefully because you need to know this in order to get a good mark. Now we are back to prove two sets are equal. Because why? This is a set. This is also a set. So to prove the image of a function is something, it's actually the same as to prove two sets are equal. And I hope you know how to do this. To prove two sets are equal, we need to prove they are subsets of each other. The first inclusion is you prove the image is a subset of the interval. Suppose it's an interval, might not be an interval. Okay, to prove the image is a subset of the interval. So what you need to do is you need to let y be an element of the image, okay, which is exactly what you do when you prove set identity. Then, by definition of image, we know that there exists an x in the domain such that f of x equals to y. So if I use my terrible example to explain this part is, if, let's say, if y is in the image, which means if what? If the boy is happy, okay, if the boy is happy, then by definition of our example, we know that someone from the girls text him, right? Does that make sense? Why we know this? So this means, well, if you are in the image, then somebody texts you, okay? So there exists a girl in the girls such that they text you. Now you need to show that your y is also in the interval. So how do you do this? Again, now I'm only talking about functions with one variable. This does not work for functions with two variables, which we'll do in a moment. So for functions with only one variable, inequality is your friend. Okay, inequality really useful here. Make sure you don't start with what you need to prove. If you want to do rough work, either you put if and only if symbol before, or you rewrite it as a formal proof. Okay, so we can have two variables or even three variables, which was actually tested pretty often in this course. Anyway, so if we only have one variables using equality, and you show that f of x is in between a and b because you want to show is in this interval. So that's the first direction, which is also the easier direction. Most students do not understand the second direction. So second direction, if we want to show the interval is a subset of my image, okay? Think about it. I want to show this is a subset of my image. So again, I pick an arbitrary element from this interval. What do we need to show? Okay, what do we need to show? we need to show you have an x in the domain such that f of x map to y. Because if you want to show y is in this, remember what do we mean by y is in the image? It means some x from the domain is mapped to them. Or if you want to show a boy is in my image, then you need to show, what do you need to show? You need to show we do have a girl who texts him, right? So this is what you need to show. Remember, this is what you need to show. It's not given to you. It's what you need to show. So to show that, the way I like the most, and it's also the way that works for either one variable or two variables. Okay, this works almost all the time, is do rough work and find your x. So remember, in calculus, you learned how to find the inverse function. This is pretty similar to that. So use rough work, try to isolate for x, write it as a function of y, okay, and then show the reader your x is indeed in the domain. So if, for example, if the domain is R, then you can show that x is in real number. If the domain is from 0 to infinity, you want to show x is indeed in 0 to infinity. It cannot be negative numbers. So that's what I meant. So you want to show your x is indeed in the domain. So for example, back to my dating show, you cannot say, oh, this guy got a text from a girl, but this girl is not in our dating show. It's just, you know, could be his mom or someone, you know. So if you found a message from a female, but this girl or this female is not in our dating show, it doesn't count, right? So anyway, so you want to show your x is indeed in my domain. And if you plug in this x back into my f of x, you can get y. Done, you're done. Okay, then you show that y is in the image. So that's how it works. Do we have any questions before I move on? People are getting quiet. This is what I don't like. Any questions? I spent a lot of time on this, so hopefully you understand this and can do it yourself. Okay, no questions. Cool. So basically, find the inverse, show that x is in the domain, show that it ends up to y. Yes. So that's for the second direction. Okay. So I hope every point makes sense to you, because you need to understand it in order to do it. I don't want you to memorize anything. For example, a lot of people don't understand, why do we need to show this? Okay, why do we need to show this? Because, well, if the girl is not for a dating show, then it doesn't count, right? I'm pretty sure every guy got a message from some girl, but is this girl in our dating show? You needed to be the dating show in order to be in our image. So that's why you have to show this. And if you plug it in back in, so what does this mean? Plug it this x back in f of x. So this means that, oh, we found a girl and they use this girl's phone to send a message to this guy. Did this guy get it? Right? So that's how it works. That's how we prove the image of a function equals to something. And I'll tell you in this course, since we get starting from the time we get online, it's very unlikely you'll see functions that has one variable and has no absolute value. So since we get online, whenever the test image is either a function with one variable but has absolute value somewhere, or it's a function with two variables. So that's what we're gonna do today. I'm gonna do the first one, which is a function with two variables. And tomorrow we will do the second one, which is a function with one variable, but it has absolute value. Can we get like 4 minutes to try? I'll let you try it, don't worry. Okay, so does that make sense to you while we're doing those two questions? Yes, okay, so we will do example 1 for it now. And if I don't get time to reach the next topic, that's okay, because we'll just do them tomorrow. Okay, so I want you to try. Of course, I want you to try because I don't want you just to listen to me. I want you to try this question. This is from last semester and it's a midterm question. So if you're retaking, I hope you know how to do this. But if it's your first time seeing this question, that's even better. Okay, try this question and I'll give you 5 minutes instead of 4 minutes. I'll give you 5 minutes to try this and I'll take it up after 5 minutes. Start now. Everyone has a copy. Can I go to the timer part? Everyone has a copy, right? Okay, I'm just gonna switch to this. Give you some pressure when you say the time. It's like you're doing a quiz. Do you not have a copy? Do you need me to send a worksheet again? I'll send a worksheet again in case anyone doesn't have a copy of the question. I do want to give you some pressure, so I do want you to see the time. Oh, by the way, we'll use the same link tomorrow, okay? I'm not gonna create a new link for tomorrow, or should I? Should I restrict it to only people who showed up today? All the other people won't know the time either. You want me to create a new link? No? Yeah, I think we can just use the same link. I'll just use the same link because you guys know the time. Yeah, this tutorial link. Okay, back to this. So, anyone has any idea of how to approach this question? I don't want a counterexample right now. I want you to tell me how exactly did you come up with a counterexample? A in 3x plus y. What do you mean A in 3x plus y? No one knows how to do this. But what about people from last semester? This was your test, so you should know. I thought out a random ordered pair that fit, then change one of the number. Oh, one of them might fit. What if you change to another number and still fit? Right? What if you change it and still fit? What are you gonna do? You change to another number until you reach something that doesn't. You should just keep trying, just change it to another number and see if it works. But anyway, here are some, I don't know, some tips that I want to give to you, because, well, the question itself, it's not as important. Of course, they're not going to give you the same question. However, so is the question basically find x, y such that it won't belong to integers? Not really. The question is you find two integers. So for example, find two integers such that g of integer does not equal to ab. Well, you cannot do that because you're from z to z. Oh, okay, this is bad. It should be thus. Sorry, my bad. This function is mapped from integer Cartesian product integer to integer Cartesian product integer. Okay, so here are my tips for you when you have a function with more than one variables. Okay, so if you see something like this, what do? Here are my tips. So let's say functions with two variables. I'm gonna be faster. I wanna do at least one question. The first thing you can do is you can compute some values and see if you can see a pattern. And see if you can see a pattern. So what does that mean? That means, for example, compute G00 and see what you have. Compute G10 and see what you have. Compute G20 or 01 and so on and see what you have. So that's one of the way you can see and just do observation and see if you can see a pattern. Okay, that's kind of like the not so smart way. The second way, what I usually do is I observe the function. I do some observation. For example, I'm using this as an example, okay? I do the observation. I see that here I have a plus y, here I have a minus y. which means if I add them together, those canceled out and I only have one variable left. So the second tip is you observe the function and see if you can use some operation to get something special or get rid of one of the variables. So you can observe the function, and you can add them together, or subtract them, use add, addition, subtraction, or multiplication, whatever you want. Multiply, to see if you can get something special. You can get something special. What do I mean special? For example, you get something that's always even, always odd, always divisible by a certain number, something like that. Number 3 is you can let them equal to a variable. Let them, I'll explain that in a moment. Let them equal to a variable. Okay, and see what happens. So you can use either of the way. And I'll show you 2 and 3 because 1 is simple. So for example, here is my rough work. Linear algebra, it's not linear algebra. So here is my rough work. Let's say if I want to use the second method. As I mentioned, I noticed that those 2 canceled out if I add them together. Then 3x plus y plus x minus y is gonna be 4x. What's so special about 4x? You don't know x, but x is an integer. So what's so special about this? This is divisible by 4. Right? It's a multiple of 4. What does that mean? That means if you pick 2 numbers, 2 integers, and their sum is not divisible by 4, then it's not in the image. Does that make sense? So any pairs whose sum is not a multiple of 4 is not in the image. So from this, I can say, for example, my counterexample could be, let's say, for example, 0, 1, 0, 2, 1, 2, anything, as long as you add them together, they're not multiple of 4, then they should not be in the image. Does this make sense to you? So this is one way of trying to figure out your example, your pairs, okay, or an element from Z cross Z. Does this make sense?
I just have a question.
Quiet again. Yes, okay.
Oh,
if
sorry.
we use the third method, okay, if we use this third method, I said let them equal to a variable. What does that mean? Let's let 3x plus y be a and x minus y be b. This is what I meant. And what do? We solve for x and y and see what x and y look like. So again, I'm gonna solve for x, y. Then I can add them together. Okay, you add them together. 4x equals to a plus b. Then x is a plus b over 4. Do you think x is always an integer? Yes, x is always integer no matter what a and b you choose. Not really, right? What if you add them is not, right? It's not really. And we can see what y looks like as well. So y will be b minus x, which is a plus, sorry, it's not b minus x, it's x minus b, sorry. Is x minus b, which equals to a plus b minus 4b, which equals to a minus 3b over 4. Do you think y is always an integer? No matter what a and b you pick? How do I know? Because I add them together, I got 4x. X is an integer, so this is a multiple of 4. Okay, again, this is not necessarily an integer. That is why the image is not all of integer cross integer. Right, so this tells you, okay, so you can just pick a and b such that x is not an integer, or you pick a and b such that y is not an integer. Why you cannot? I'm just doing some observation and see if there is a pattern. This is my rough work. It's not a proof or anything. I'm just trying to see if there is a pattern I can figure it out. So from this, I see that the sum has to be a multiple of 4. Or sometimes, well, if, for example, if this is 3x, you can also use this minus this, and you'll get something, maybe, you know, I don't know. It depends on the function. Okay, so I got something. So you can either use this way or this way to show that, well, I have to match certain things for it to be a function. So we can just use, for example, 0, 1. So here is the actual thing right on your quiz or right on your whatever you're doing. So now I'm gonna claim 0, 1 is not in the image. Okay, I'm gonna show you how to write a thing. It's not a proof. Yeah, it's not a proof. Here, rough work, do you not see it? I'm just trying to pick an example. Yeah, and then we'll show it's not in the image. So now I'm gonna show 0, 1 is not in the image. So if it's in the image, if 0, 1 is in the image, sorry, it's G. So if it's in G, Z cross Z, then you would have 3x plus y equals to 0, x minus y equals to 1. You don't need to because it's pretty obvious. Okay, you can add it here. You can add it here, but you don't have to. It's better that you add it here so it's more clear. Okay, so now you need to solve this. So this is 1, this is 2. You add them together to cancel out one variable. That's gonna be 4x equals to 1. So x equals to 1 over 4. Right, now solve for y. So we can sub in number 2. That's gonna be I wanna do y. So y 1 over 4 minus y equals to 1. Y is negative 3 over 4. Okay, so I got my x and my y. And if it's in the image, then this pair should be in this, but it's not. But 1 over 4, negative 3 over 4 is not in the domain. What does that mean? So I'm saying, oh, this is a guy in my show, and this show, no, this is a boy in my dating show, and this boy said he is in the image. I'm gonna show he's not in the image, so I'm trying to trace the message he got from a girl, and I realized, oh, the girl who sent him the message is not from my dating show. Okay, So you can, in this case, you can say that, oh, this boy is not in my image. So 0, 1 is not in the image of G. Sorry, this should be G, not F. Not in the image of G. Does this make sense? Does this make sense to you? How we got this? Of course, you can use the other ones, so you can use any of those, or you can even do like 3, 3, 2, which also works. Questions? Big curly bracket. This. Okay, so I'm saying if this is in the image, okay, which means this equals to 0, 1, right? That's what it means for it to be equal. That means since this equals to 0, 1, that means this equals to 0, this equals to 1. Or we can add one more sentence. So let's say then gxy equals to 0, 1. How about that? And you have this, which implies that. Okay. Any other questions? Anything else you need me to explain? I see what you did, basically just plug in and solve it like a system equation. That's exactly what I did. Cool, any other questions? So we don't have time to do more, so we'll do the rest tomorrow. Cool. Yeah, the pink part is what you write on your quiz. The pink part is what you write on your quiz. This is rough work, and this is what you should write on your quiz. Are we having tutorial in person next week? Yes. Everything is in person next week. Unless you are in lecture 9103, then you have your lectures online. I'm so hungry now. All right, if you have no question, you can leave. I'll see you tomorrow if you have time tomorrow. Otherwise, we'll see. Bye.